Hello Amartians, my name is Manoj Kumar. Now I am uploading my next video, and in this video we will start chapter 5th. The name of chapter is here complex number and quadratic equations. So in previous classes what we have done, we have studied linear equation in 1 and 2 variables and the quadratic equation in 1 variables. So we have seen the equations like x square plus 1 is equals to 0 has no real solutions. So what is the value of here? X square is equals to minus 1. The square of every real number is non-negative. So we need to extend the real system to large the system so that we can find the solutions of this type of the equations. So in plus 1 class we will learn when we have quadratic equations have no real roots, how we can find the solutions of this type of the equations. Before start chapter 5, you will see the mind map of this chapter. The name of the chapter is here complex number and the quadratic equations. So in first step what we will do the introduction of a complex number, then meaning of complex number, then algebra of complex number. So in algebra of complex number we will discuss the different properties of the complex numbers, and then modulus and conjugate of the complex number, and argand plane and polar representation. Then we will solve the quadratic equation which having non-real roots. Once again you can see in introduction of the complex number, in earlier classes we have studied the linear equation in 1 and 2 variables and the quadratic equation in 1 variables. But we have seen this type of the equations such like x square plus 1 equals to 0. Please note down, when these type of the equation has no real solutions, we have done this type of the quadratic equation which have real solutions. But in plus 1 we will learn how to find the solutions of those equations which have no real solutions. You can see here this one under root minus 1 which is equals to iota. This small I is known as iota, and the square of this iota square is equals to minus 1. Please note down. See the definition of the complex number from here. A number of the form a plus iota b where a and b are the real number is defined to be a complex number. See the examples of the complex number. These all are the examples for a complex number. And complex number is always represented in general form z is equals to a plus iota b, where a is called real part and it is represented by rez, and b is called imaginary part and it is represented by, and b is called imaginary part and it is represented by imz of the complex number. So here suppose z is a complex number which is equals to 2 plus iota 5, then real part of this complex number is here 2 and imaginary part is here. Imaginary part is here, you can see 5. Now you can see few important results. If two complex numbers here you can see z1 and z2. Suppose they are equal, then you can compare a is equals to c and its imaginary part is equals to its imaginary part. So we can say here a equals to c and b is equals to d. Now see, I am going to start the first example. Here in this example they have given left hand side is one complex number and in right hand side also another example, but both are equal. Already they have given both complex numbers are equal. Then you have to find the value of x and y. So what you will do, just now we have done, when two complex numbers are equal, so we can compare their real parts and imaginary parts. When you will compare real parts, so you will get here 4x is equals to 3, and when you will compare your imaginary part you will get this part. And from first part you can see from here you will get here the value of the x and put this value in this equation, and after substituting the value of the x you will get the value of y. So now in this topic we will start algebra of the complex number. So in this section we shall develop the algebra of the complex number. You can see the first is the addition of the complex number. When you have two different complex number z1 and z2, so what is the sum of these two? You can see here, just you can add real part to real part, so you will get here a plus c, and only you can add its imaginary part to imaginary parts. So the sum of z1 plus z2 is equals to a plus c plus iota b plus d, so which is again complex number. Now you can see the addition of the complex numbers satisfy the following properties. First is closure law, second is commutative law, third one is associative law, and the fourth one is existence of the additive identity, and then the fifth one is the existence of the additive inverse. So just like additions, so we can difference of two complex number. Given any two complex number z1 and z2, the difference of these two numbers z1 minus z2 is defined as follow. In same way you can see here example this one. So let us suppose your z1 is here 6 plus 3 iota and z2 is here 2 minus 1. When we will subtract these two complex number, so only you will subtract real part to real part and imaginary part to imaginary parts. So after subtraction you will see here, you will get here 4 plus 4 iota. Now we will start the multiplication of the two complex number. It is also simple multiplication. Suppose we have first complex number is here z1 is equals to a plus iota b, and the another one is z2 is equals to c plus iota d. So the product of z1 and z2 is equals to here, you can see this is equals to this one. So when you will multiply them, so each term of first complex number multiply with the each term of a second complex number. So after simplification you will separate its real parts and imaginary parts. So then we will get here AC minus BD plus iota AD plus B square. You can see its example here, this one. So 3 plus iota 5 first complex number, and second one is here 2 plus iota 6. So you will use our result when you will compare here your A is equals to 5, B is equals to, A is equals to 3, B equals to 5, and C equals to 2, and D is equals to 6. So when you will off the brackets of the first term and multiply with the each term of the second terms, you will get this result. And after simplification, you will separate your real parts and imaginary part. And here we will get here this result. Now, the multiplication of the complex number possess the following properties, which state the without proofs. The first one is closure law, second one is commutative law, then associative law, and the existence of the multiplication identity, and the next is the existence of a multiplicative inverse. It is very important. And then next one is distributive law. So these are properties for multiplication of a complex number. Now student, we will start division of the two complex number. So let us suppose two complex number here, z1 and z2, where z2 is not equals to 0, and the quotient z1 upon z2 is defined by z1 upon z2. And let us suppose your first complex number is here z1, and z1 is equals to 6 plus 3 iota, and z2 is equals to 2 minus iota. So you can see here z1 upon z2 and substitute the values of z1 and z2. You will write down here z1 and z2 6 plus 3 iota multiply 1 upon 2 iota. And remember students, when any complex number is, we will use this identity, this one, existence of the multiplicative inverse, and we can write down our complex number in this form: a upon a square plus b square plus iota minus b upon a square plus b square. So same identity we will use here. So you will get here 6 plus 3 iota, and in place of a you will write down 2 upon a square plus b square plus iota minus b upon a square plus b square. This is a very important way, and then simplify it and you will get your division of a two complex number. And this is the solution of this question. So now next topic is power of i's. It's a very important, and you will learn these all, the powers of I. If suppose I raised to power 3, so it is equals to minus I. Suppose I raised to power 4, which is equals to 1. And you will suppose I raised to power 5, and it is again equals to I. And the basic concept is here, you will remember I raised to power square is equals to minus 1. It is very important. And please note down I raised to power minus 1, this one, and minus I square is equals to I square, which is equals to minus 1. So therefore the square root of minus 1 is iota and minus 1. And however, why it is represented by its under root minus 1, and which means under root minus 1 is equals to iota only. Now student, you can see the second example. They have given some complex number, and we will express the given complex number in the form of a plus iota b. You can see the first part, what they have given, minus 5 iota into 1 upon 8 iota. But we will do, we will multiply iota and iota, it is equals to iota square, and we know that iota square is equals to minus 1, and we can simply multiply This is 5 minus 5 upon 8. So here we will get 5 upon 8, but you can see iota is missing here. So we can write down 5 upon 8 plus iota 0. Now you can compare, your real part is here 5 upon 8 and imaginary part b is equals to 0. Now in same way you can solve its second part. Say second part what they have given, minus iota 2 iota minus 1 upon 8 iota whole cube. So when you will multiply all these iota, you will get here iota raised to power 5, and we can write down this in the form of iota square raised to power 2 multiplied by iota, and multiply these all and you will get here 1 upon 256, and when you will simplify this term you will get here 1, and the value of this I raised to power 5 is equals to iota. You can see here. So you will get here 1 upon 256 iota, and when you will express in the raised to power, so you will write down here in a plus iota b 0 plus 1 upon 256 iota. This is our required solution. Now student, you can see the third example. Here we can express 5 minus 3 iota whole cube in the form of a plus iota b. So here you will use this identity a minus b whole cube, which is equals to a cube minus b cube minus 3a square b plus 3a b square. So by using this identity you will get here this one, and after simplification please note down iota square is equals to minus 1 and iota cube always equals to minus iota. So we will use these things, and after simplification you will get here 125 minus 225 iota minus 135 plus 27 iota, which is equals to, so minus 10 minus 98 iota, which is in the form of a plus iota b, which is our required. So in same way we will solve most of the question of exercise 5.1 1 to 10. We will do same question like this, and we will convert in the form of a plus iota b.